Hey guys, so I'm going to go ahead and go over the Mark-Recapture data analysis for this week's lab. Let me just share my screen. So you're going to get your data for this week, and it's going to be some data that we used a couple semesters ago because the data was a little skewed and it wouldn't have given you any good results. This data that I'm going to use to do the tutorial is mine from last semester, so nothing that you have for yours. So you're gonna have just this data right here. Just ignore the rest. And then you're gonna have a section for riffle and a section for pool, and the total marked individuals, the total captured individuals, and then the total number of recaptured individuals. Of the 211 captured, 3 of them were recaptured, as in they were marked initially when we went out. So that's the same for the pool. The only thing different that you're going to have is you're going to have 3 data points for dissolved oxygen and temperature for each microhabitat, and you're going to have to take the means of those 3 to get your DO and temperature. So there's just a couple of calculations to do for this lab. It's nothing too difficult. Some of them I'm not going to do on the spreadsheet in a formula because it's just too many parentheses to get it right. But it's really simple. So the first calculation you're going to do is big N. That's going to be for population estimate. For the riffle section, equation will go like this. You're going to take the total marked, between 93 plus 1, and then you're going to take the total recaptured, which is 211 for this one, plus 1. And then we're going to divide all of that by the number of recaptured individuals plus 1. So it's going to be 3 plus 1. And then all of that will be subtracted by 1. I never get these parentheses right. All right. So I'm gonna do it one more time for the pool. Me down here, the number of marked individuals plus 1. The number of recaptured individuals plus 1. And divided by the number of recaptured individuals plus 1. And then subtract all of that by 1. Okay, so these are the population estimates for the different microhabitats. Now we want to do our standard of error. I have the formula up here for reference to see. So the standard of error is a much longer one, and I would recommend doing that by hand, just because it can get messy in Excel. For standard of error for the riffle, I had 4,232.48. So I'm just gonna put that in so I can calculate the rest of them. And then for pool, it was 816.16. If you have any problems calculating this, formula is right here. M is just the marked individuals, N is the number of recaptured individuals, or the number of captured individuals, and R is the number of recaptured individuals. So you're just throwing those values in this equation and get your standard of error. You should have done it lots of times by now in other classes. Same thing with the confidence interval. It's a little bit different because you're going to take the sample size plus and minus t times the standard of error. T in this case is our critical value, and we're going to have it be equal to 1.96. I'll write that. So for the riffle, it's going to be 4,981 plus minus 1.96 times standard error. When you report the confidence interval, you're going to put it as, like I have up here in this table right here, it's going to be n plus SE. So don't do what I just did and added the n to it. Again, for clarification, the confidence interval is going to be the critical value 1.96 times the population estimate. So right here, I'm just calculating this part, and then you add the n, your population estimate in front of that, like it is here when you do your tables. Density is going to be, again, the population estimate divided by 100 meters. And it's 100 meters because we should have taped out a 10 meter by 10 meter area to do sampling in. So our total area is going to be 100 meters squared. And then it's going to get you, for a riffle is 49.81. And then we'll do it again for pools. And it's be a number, the N, big N, population size divided by area. And that's your density. Finally, for the t-test, you're going to do your t-test by hand, and this is the formula that you're going to use for it. You're just taking the sample, your population estimates for riffle, subtract the population estimate from the pool, and then divide that by the squared standard of error values that are added together, and take the square root of that. I'm not going to do it on Excel because I don't like doing square roots on Excel. I have the values up here already, or it's just one value because you're comparing both habitats. From last semester, I got a value 1.85, and our critical value is 1.96. Our t value was less than 1.96, so we're going to fail to reject the null hypothesis. In this case, if it was greater than 1.96, you'd reject the null hypothesis. I was just telling you if you have a difference in the population estimates or the population density between the riffle and the pool. So this is your stats table. Most of the information that you just did is going to go in one of your tables. And then you're going to have to make a graph, a bar graph with your population estimates and your standard of errors. So your population estimates are going to be your bars, and then make sure you include your standard of errors. And then that's it. I included an outline for your report, for your Mark-Recapture report. If you have any questions, just ask me on the Discord. Otherwise, I hope you have a successful writing weekend. Take care.